Number 6 on the 2019 AP Calculus free response. It is one of the hardest problems they ever put on there, in my opinion. So actually the first couple seem difficult, but once we realize what they're asking, then it should be pretty easy. Then we get down to part C and D, and that's where things get a little tricky. So let's just go ahead and start. FGH, twice differentiable. So we can take the derivative. That's going to come in handy later. They always tell you stuff you need to know most of the time. G of 2 equals H of 2 equals 4, and that's going to come in handy as well. They give you a lot of information, which can be overwhelming. And then they tell you that this line is tangent to G and H at 2. So there's a lot of stuff going on here. So first of all, number 6, part A, where it says find H prime of 2. My first thought when I read this was, well, I need an equation. I got to find H of 2, H prime of 2. I got to take a derivative. No, I don't, actually. I need to know the slope at 2. The slope at 2 is the slope of the tangent line, and they told me the equation of the tangent line. So basically, and you don't have to write all this down, but I'm dealing with this little guy right here, and that is my slope, so the answer is 2/3. Okay, so that was part A, and it was pretty straightforward once we realized what we're doing, because we get in a habit of finding a derivative, and there was no derivative to find. Like, they never told us the actual function, but they did tell us in a roundabout way the slope at 2. Okay, so there's part A. Here comes part B. They said A, oh, now we have another derivative, another function. So A is 3x cubed h of x, and then we're going to write an equation for A prime and find A prime of 2. So let's just go ahead and find the derivative. And this is going to be a product rule. So 3 times 3 is 9, 9x squared. So f prime g, or h in this case, plus f g prime. And now we want to find out what happens at 2. And so at this point we might look at it and say, well, there's a lot of stuff I don't know. That's okay, we'll tackle it later. Often we may not know what we don't know until we get into the problem. And that might seem a little wordy, but when we read a problem, it's easy to look at the problem and say, well, I don't know how to tackle it. Well, take a guess and just start running with it. And then you'll find out what you need in the process. I'm thinking of related rates when I say that. I'm a little off track right now. Sorry, I'm off on a tangent. But I may not know h of 2 and I may not know h prime of 2. Actually, I do. But I didn't know that I needed to know them until I got into the problem. Anyway, sorry, I'm rambling. Let me keep on going. 9 times 4, so 36, h of 2. And then 3 times 8, so 24, h prime of 2. And actually, I do know all this stuff. I didn't know it at first. I needed to know it, but now I know it. I'm talking in circles. I apologize. 36, h of 2. Well, they told me that. It was 4. And 24, h prime of 2. And they didn't tell me that, but they told me that. It's 2/3. That happened in part A. And the way they've always graded in the past is if you get this wrong, but you use that here, you're good. You'll get that one wrong, but they'll give you credit for it because you're continuing the process correctly. So we end up with 144 plus 16, which is 160. And when I said you don't have to simplify things, I firmly believe that they would let you keep it right here at this step, which would help us avoid careless errors. So you could do that. Let me just go ahead and tell you that by doing everything we've done so far, we've earned 4 out of 9 points. I know the grading scale will be different this year, but we've earned 4 out of 9 points. We earned 1 point here. We earned 3 in the process of doing this. This was worth a point. And then, and actually that was worth 2 points. So product rule and then the actual derivative and then the final answer, which was 160 or something that leads to it in this case. Okay, let's earn the other 5 points. And now things get a little bit tricky. So the function h satisfies that for x not equal to 2. Okay, so x can't equal 2 in this case for some odd reason. It is known that the limit as x approaches 2 can be evaluated using L'Hopital's rule. Okay, now there's a lot going on here, and I'm going to do this one in the same way that I went through it in my thought process when I worked through it, which is generally the way I do this, because there's something that we should notice from the beginning that we didn't, and I didn't, and I'm just going to pretend like you didn't either. And then that might help us in our thought process as we try to figure this out. So I personally like to just think my way through things by writing stuff down. and I'm just writing this down. Now, I know nothing about f other than the fact that it's differentiable twice. Like I could take a derivative and a second derivative. I still don't know what those derivatives are, but that's all I know. But I know that I can find the limit as x approaches 2 of h of x. I'm going to write all this again because I think it'll sort of help me explain things. I can find that using L'Hopital's rule. Now, we remember L'Hopital's rule being if you get an indeterminate form like 0 over 0 or infinity over infinity, and that actually happens here. So you're going to have 2 squared minus 4. So the numerator is 0. So I'm grabbing a scrap piece of paper, a little post-it note over here, and I'm going to write something that's highly illegal. Please don't write this on your exam. This is equal to, direct substitution, 0 over, well, if I'm going to use L'Hopital's rule, then it better equal 0. Okay, so technically this doesn't equal 0 over 0, so don't put this. But they said that it can be evaluated using L'Hopital's rule, meaning this is going to give me an indeterminate form, and that's it. It has to be 0 over 0 because the top is 0. So here's what I started thinking. I thought, well, if I was to use direct substitution, then, and I am going to write this because this is part of the thought process, then this denominator, f of 2, all cubed, is going to give me 0. Because of this. Because they said you have to L'Hopital this thing, and so the denominator has to be 0. So I'm going to solve this thing for f of 2. I'm going to treat this like a variable. So let's just bring it over. So 1 equals f of 2 cubed. We'll take the cube root of 1. So f of 2 equals 1. Yay, we found it. And that actually is going to be worth 1 point right there. So we have a few more points to earn on this little sucker, so let's keep going. They also want us to find f prime of 2. So my next thought was this, and I'm going to use another piece of paper for this, and not the one I'm working on because this little train of thought got me nowhere. I thought, well, maybe if we L'Hopital this thing again, then we'll have another 0 over 0. So like, you take if you have to L'Hopital it because it was 0 over 0, and I'm just going to keep going here, then I would take the derivative of the top, I would take the derivative of the bottom, so 1 goes away, and then negative 3 f of x squared times f prime, it's chain rule. And then I'm hoping that this happens. But I'll tell you, actually, it's not going to happen, because if I plug in a 2, I have a 4. So L'Hopitaling again to find this is not going to work. It's not really going to work at all. Okay, but here's where the thought process started taking me. So I had to take the derivative to get there. So I'm gonna write this on my paper. I know I kind of scribbled it over here, but I put this over here saying, well, maybe I'm gonna have to do something else with it. I'm rambling. I apologize if I'm making no sense. Okay, I had to L'Hopital, so everything I just wrote, I will continue to write. So the limit as x approaches 2 of x squared minus 4 over 1, so sorry. It's, if I'm not speaking clearly, it's my fault. Okay, I wrote this on a separate piece of paper a minute ago, thinking that it was going to be one of these things where I have to L'Hopital again. I apologize for wasting your time with that. But anyway, so, oh man, I messed up again. I'm sorry. I would start the video over, but the explanations so far are somewhat sufficient. I apologize. There we go. This is the next step from L'Hopital, okay? I have found one of the things they asked for. Yay! And this is the next step from L'Hopital. When I grabbed the extra paper, I was thinking I'd have to L'Hopital it again and again just to get this thing to work, and I was wrong. Taking you through my thought process, muddled though it may be. I hope we're okay so far with the fact that I had to set this denominator equal to 0 in order to realize that L'Hopital had to be used because I couldn't use direct substitution. Hopefully we're all on the same page. Sorry for any confusion. However, if I was to plug in a 2 here, I don't get 0 over 0. So I don't L'Hopital again. That's where I was going with the other train of thought that got me nowhere. Sorry. But if I plug in a 2 here, and I'm going to do that, then I'm going to have 2 times 2 over negative 3 f of 2 squared times f prime of 2. And then I froze for a second when I was working through this myself, and I thought, oh, that's great, but I don't know what that is. So, I can go a little further with this, and I can say, well, this is really 4 over negative 3 times 1, right? Because we know what that is. So negative 3 times 1 squared. So this is negative 3 f prime of 2, but I still don't know what that is. And I thought, well, how in the world am I supposed to find anything? I kept looking through the problem saying, well, I have to know something about f. But I don't, other than the fact that it's differentiable. And then it dawned on me. Here we go. Not only is f differentiable, h is differentiable. So I can take the derivative of this thing and it works. Because it's differentiable, it's continuous. So, and I'm thinking way back to the chapter on continuity. I believe it was chapter 2, yeah. So when it's continuous, if a function is differentiable, then it is continuous. If it's continuous, then its limit from the left and its limit from the right, well, first of all, they equal each other, and they actually equal the value of the function. And the value of the function at 2 is 4. And so all of a sudden, it hit me that this entire thing had better equal 4. So the limit as x approaches 2, I'm going to jump right back here, and I'm going to say, you know what, this equals 4. And because this equals 4, and maybe this gets me nowhere, but because this equals 4, then L'Hopitaling it is going to give me 4. And then I can cross multiply. I'll make it 4 over 1, so 4 equals negative 12, f prime of 2. And so that gives me negative 1/3 equals f prime of 2. I feel like I've done a terrible job explaining that, so let me tackle it one more time. Hopefully we're okay with this part. But because f is differentiable, it's continuous. Because it is continuous, then the value of the limit is equal to the value of the function. And I think it's probably worth writing over here on the side for the sake of explanation. So the limit as x approaches 2 is equal to the value of the function at 2, and that's equal to 4. And so by the time I got down to here and I was scratching my head saying, I can't find f prime. Oh, wait, I can, because it's equal to 4. Okay, this takes us to part D, where things get really interesting. And this does look kind of out of the ordinary, but they're asking for continuity. Well, what has to be true for something to be continuous? Well, the value of the function has to equal the value of the limit, and the limit has to exist. So let's just go with it. If it's going to be continuous at 2, then the value of the function has to equal the value of the limit. Now, there's this really obscure theorem called the Squeeze Theorem that I mentioned a couple times, and it is actually mentioned in their answer key. So let me just set your mind at ease here. First of all, I don't think you have to use the phrase Squeeze Theorem. Second of all, this one was only worth 1 point out of 9. So, you can still make a 5 and not get all 9 points. So you're good, all right? But we're going to do it anyway. So here goes. And when I saw this one, I had to visualize it. So G is below H. So I'm just drawing here. So G is below H from 1 to 3. So your first thought, and everything I'm going to draw, it might not be right, but it's just a thought process, okay? So if you're writing this, don't panic. So here's H, and here's G, okay? So G is less than or equal to H from 1 to 3, and we have a volleyball net. Let K be a function such that K is between them. Okay, so now we have another function in the middle. I don't know what it's doing, but it looks like this, maybe. And it's in between them from 1 to 3. Is K continuous at 2? Can we say for sure that K is continuous? And I want to justify my answer. So again, if it's going to be continuous, then I'm going to need to say a couple things. I'm going to need to say that, and I'm just writing over here the stuff that I eventually really need to say. Okay, so I need to say that k of 2 exists, and I also need to know that the limit as x approaches 2 for my function, or for k of x, is equal to the actual value of the function. Well, all right, here's the fun part. We actually know what k of 2 is. And I know you're probably thinking, well, we never were told anything about k. We actually sort of were. So here it is. G of 2 and h of 2 is 4. All right, so let's redraw our picture. And again, you don't have to draw all this to get any credit. This is something that happens in our head. And this really did happen in my head. And then it dawned on me, wait a minute, this function and this function at 2 are actually, I'm going to use the word they used, squeezed together. So let's visualize it. So here's h of x, and maybe it looks like that and maybe it doesn't. And here's g of x, and maybe it looks like that and maybe it doesn't, but what I do know is they touch each other right there. And there is 2, x equals 2. And they're asking, is it continuous from 1 to 3? Is the function in the middle continuous? Well, if the function's in the middle, then it is, here I go using that word again that I barely taught you, but that's okay. Really, it is okay because we visualize it. Because it's squeezed in between. All right, so this is a lot to piece together, and let me, again, comfort you. This was only worth 1 point. So again, another piece of advice. Do the ones you know how to do. All right, so my mind just went blank. I want to talk about the fact that k of 2 exists, and I want to talk about the fact that the limit equals the value of the function. So let's talk about the fact that the limit exists. So let's do a couple things. I'm trying to piece my thoughts together, and it's difficult for me to do at this hour, but we will keep on moving because this is fun and because I care. Because g of 2 equals h of 2, which equals 4, and k is stuck between them, that's also k of 2. All right, so I'm just kind of writing down stuff that by this point we know. So this point right here is 2, 4 for all 3 functions. So k of 2 exists, check. Now, because we have squeezed it between the others, if you don't use that word, it's fine. But because g of x is less than or equal to k of x, and I'm just writing down what they told me, less than or equal to h of x, for all the stuff on the interval from 1 to 3, the limit as x approaches 2, k of 2 is equal to 4. And their explanation, again, was the squeeze theorem because it's stuck in between them, so it's going to have to. And so because the limit exists and the limit equals the value of the function, oops, that should say x right there. K of x is continuous at x equals 2. Okay, terrible job explaining it. I apologize. So let me try to recap it one more time. When we get a visual, we begin to understand it. Knowing that h and g meet at this point and k is in the middle, so it has to exist there. Because it exists there, its limit is also going to exist. It's going to approach the same value. So if a limit exists, it meets the same thing from the left and the right, and it's actually the same as the value of the function. We have met the 2 criteria for a limit for a function to be continuous. The value of the limit equals the value of the function, and there we go. That was the shorter explanation. If you have any more questions, please let me know.